The final example of nucleophilic substitution is with ammonia. The reagent, unsurprisingly, is ammonia. The conditions that we can talk about is that the ammonia is in excess as well as being in ethanol. To start with the ammonia, we're going to skip forward to the mechanism to see if we can go back and then work out what's happening with the equation. There's a reason for why we're doing this. The ammonia as a nucleophile is different to the others in that it doesn't have a negative charge, which means it doesn't have an electron which is spare to give away. So the lone pair, which it's going to be reacting with the carbon, they both belong to the nitrogen, so it doesn't really have an electron to lose. Let's have a look at how the mechanism unfolds. So again, starting off with a nice easy mechanism. So there's our ammonia, and just like before, we've got the lone pair on the nitrogen attacking the carbon, and we're displacing the chlorine. So it looks same as all the others, however there's a difference here. See if you can draw what you've got at this stage. So that's what I get from attacking with the ammonia. Just have a look at what I've got at this stage. See if you can spot a mistake with what I currently have. So the issue that we've got here is that nitrogen has given an away electron that didn't belong to it. So that nitrogen is now positively charged. Whenever you see a nitrogen with 4 bonds, it will have a positive charge on it. You can see I've got my chloride ion. That's fine. What we now need to do is to lose one of those hydrogens and give the nitrogen its electrons back. And the way that it's going to do that, because the ammonia is in excess, another ammonia is going to come along and remove one of those hydrogens as a hydrogen ion. So there's another ammonia entering. Could pick any of those 3 electrons off. I'm just going to pick that one, and then the pair of electrons bonded between the nitrogen and hydrogen go back to the nitrogen. What will that give us? So there's our organic product. It's an amine, and there's just 1 carbon in it, so this is methylamine. In addition to the chloride ion, we now have generated an ammonium ion. So quite often you'd put down those 2 together as ammonium chloride as the other product. What we can also see here is that we had 1 ammonia in the first step and then another ammonia in the second step. So for each of our equations we're going to need 2 ammonias involved. So our general equation will take this format. As you can see, there's 2 ammonias for each of the halogenoalkane. There's our organic product. That's our amine, and then we've got the ammonium halide salt as the other product. So another example of an equation. If we started off with iodomethane, so we can put down our 2 ammonias. It's going to give us methylamine as well as ammonium iodide. Have a go at doing this next one. We'll do chloroethane. Again, we can confidently say that there's going to be 2 ammonias involved. So there's my organic product. Have a go at naming it. Well done if you got ethylamine. Let's have a go at these three balanced equations below. So for the first one, remembering we needed 2 ammonias, and we will for each halogen that we've got. Our organic product this time has got 3 carbons followed by the amino group, so that's propylamine. Have a go at the next one. There we go for the second one. Slightly strange name, cyclohexylamine. You might also see that referred to as aminocyclohexane. And have a go at the third one. Watch out, there's 2 chlorines for this one. So there's our product this time. We've got the chain of 3, and because we've got chlorine on the first carbon and a chlorine on the third carbon, both of those have been substituted with amine groups. That means in total that we needed 4 ammonias for this. In terms of the name, we have a chain of 3 carbons. Our amine groups are on the first and the third carbons. And we've got propane 1,3-diamine. So back with the mechanisms. Have a go at doing the mechanism between bromoethane with excess ammonia. So there's our bromoethane. Let's bring in the ammonia. See if you can put the curly arrows on here. So again, nucleophile attacking the electron deficient carbon, kicking the bromine out. What will that give us? Well, in the first instance, we've got that, in addition to the bromide ion that we've removed, remembering that the nitrogen has a positive charge on it. So let's bring another ammonia in to give the nitrogen its electrons back by removing a hydrogen. I'm going to pick on this one here, and that means that those electrons will go to the nitrogen. Nearly finished. So here's our organic product. So we've made ethylamine, and the NH3 has become NH4+. So as well as the bromide, we've got ammonium, so we've got ammonium bromide in addition to the ethylamine. Name of the mechanism, same again, nucleophilic substitution. Finally, let's have a go at this one, 2-iodobutane with ammonia. So I'm drawing my organic out slightly differently this time, just to get used to seeing it in different ways. So hopefully we're happy that that is 2-iodobutane. So if you count the carbons there, you can see the longest carbon chain is 4. If I bring my ammonia along, I'm going to attack from over here this time. So that's meant to be 1 arrow, and then we're displacing the iodine. Okay, what will that give us? So we've got that. Again, let's bring the ammonia along, finish the job off. In addition to our iodide ion, and then our final product, so there's our final products. We'll have a look at the name of this amine. Names of amines can be really tricky. The longest carbon chain, including the nitrogen, is that one there, which makes it propylamine, and we have a methyl group on what would be the first carbon, so that makes it 1-methyl propylamine. There's another way to name this, and that is to call the NH2 an amino group and just place the amino group on a carbon chain, the same as you would a halogen. And in that case, the carbon chain is 4, so it's butane, and the amine group, or an amino as it's known, is now on the second carbon, so you'll also see this referred to as 2-amino butane. Confusing.